Alright, so in the last video we talked about introduction to calculus, and now we are going to start off with differential calculus with our first question: what is a derivative? Well, to give you an informal definition, derivative of a function, say f of x, can be said as the ratio of change in output to change in input. Take a look at this graph. Say this is a graph of some function f of x, and let f dash x be the derivative of the function f of x. So f dash x is defined as limit delta x approaches to 0 delta y upon delta x, where for time being you can ignore this part, limit delta x approaches to 0. Now that we have met the informal definition of a derivative, let's move to a bit more formal one. So take a look at this graph. Let's say this graph is of some function f of x, and I have this point f of x plus h on the y-axis corresponding to a point x plus h on x-axis, and again I have a point f of x on y-axis corresponding to a point x on the x-axis. Let us assume that f dash x be the derivative of the function f of x. So f dash x is defined as f dash x equal to limit h approaches to 0 f of x plus h minus of f of x divided by h. This is also called the first principle, and this is also the definition of a derivative. Now, what does it means when I say limit h approaches to 0? Well, again, take a look at this graph. I have 2 points, x and x plus h on the x-axis, and I have this region of space between these two in the shape of a trapezium. When I say limit h approaches to 0, then I mean that this whole gap between the x and x plus h, it reduce to 0, so that x and x plus h now are no longer two different points, they are a single point, which turn this trapezium to a single straight line. And the line touching this point, touching the graph at this point, is called as the tangent to the curve, and the slope of this line is actually the derivative of the function. Now that we have learned about the first principle, let's use the first principle to calculate some derivatives of the function. Suppose we have f of x equals to 1 upon x. So by definition, I can write the derivative as f dash x equals to limit h approaches to 0 f of x plus h minus of f of x upon h. So f dash s equal to limit h approaches to 0 1 upon x plus h minus of 1 upon x divided by h. So f dash x equals to limit h approaches to 0 x minus h upon x plus h into x into h, where x and x cancelled out, x limit h approaches to 0 minus of h upon x plus h into x into h, where again h and h cancel out, limit h approaches to 0 minus 1 upon x plus h into x, and here we go, minus 1 upon x plus 0 into x is equals to minus of 1 upon x squared. So the derivative of function is equals to minus of 1 upon x squared. Now let's try a derivative of a trigonometric function. Suppose I have f of x equals to sine of x. By definition, I can write the derivative of f of x as f dash x equals to limit h approaches to 0 f of x plus h minus of f of x divided by h. So f dash x equals to limit h approaches to 0 sine of x plus h minus of sine of x upon h. We know sine a minus sine b equals to 2 cos a plus b by 2 sine of a minus b by 2. Then f of dash x equals to limit h approaches to 0 to cos 2x plus h by 2 sine of h by 2 divided by h. F dash s equals to 2 limit h approaches to 0 cos of x plus h by 2 limit h approaches to 0 sine of h by 2 divided by h. F dash s equal to 2 cos x limit h by 2 approaches to 0 sine of h by 2 2 into h by 2, where 2 and 2 cancel out, and it turns out to be cos dot 1, because limit x approaches to 0 sine x upon x equals to 1. So derivative of the function is cos x. Thank you for watching this video, and stay tuned for the more videos on the calculus.